Okay.
Derek sent a text to his parents last night saying that nobody was here.
First, I'm going to put an example on the board. Here's what I like you to do. Okay. Okay, I'm going to have you write down this first problem real quick. Here it is. Everything we're going to do today is based on this first problem. Alright. Hey, I'm not going to stop people from talking today. I'm not going to do it. If you want to talk, get out. I'm not going to do it today. We have too many things to go over. If I have to stop and correct people and try to shush people, just get out. I don't want to do it today. I'm in the mood for it. So you've already been warned. So I don't want to stop people from talking. You should be in here trying to pay attention anyways. Because today's stuff, I'm warning you right up front. Today's stuff is going to take me almost all the way to the end of class, and probably won't have a break to even stop to think about it. We have a lot of stuff to cover today. We have to cover differential quotient. We have to cover quadratics. We have to cover how to find the max and min, the relative max and mins using differential quotients. Like this stuff we're doing today is tough alone, doing one at a time. I'm doing one problem that's going to take me almost all class. So you have to think about like the level of difficulty that we're in now. Now we're mixing everything together. I'm not going to be doing the end behavior stuff. I'm going to take that for granted. We're just going to jump right in. I'm not going to put that list and outline up here again. We need every bit of board space we can get. The big thing here, this is a cube graph. You already know all the little details about it. Okay, cube graphs go opposite directions. If it was negative, these tails would go the opposite directions. The problem is I don't know my x-intercepts. And that's the whole point of what we're doing today. Figure out x-intercepts and figure out all the parts of them. Okay, y-intercept, if you know my y-intercept is at negative 40. We're just going to jump right off to the bat. Okay, the problem is I have no idea in the middle where we're hitting. You know, I know roughly this is kind of what the graphs typically look like. Okay, and I know that I have to go through negative 40. So this graph isn't even drawn correctly. It's drawn more like this. And again, that's whether it's actually doing that dip right at negative 40. So what we're going to be finding out today is, does it have x-intercepts? Like, what are these locations? That's what we need to focus on. That's the first part today, the first half. The second half of class will be focused on, now that we know our x-intercepts, where are these dots found for the min and max? Like, where are they going to be located? Because I don't even know if it's at negative 40. Now, why we're doing this. This is going to be one of the problems on your test. The test for us is coming up. We're almost to the end of the section. I'm thinking like next Tuesday time frame, we're going to be looking at maybe a test mirror. So by the end of the week, we'll probably have a practice guide in hand because we only have a couple sections left. And we're mixing everything in together at these last few moments. There's only a few sections we have to do separate, and that's coming up tomorrow and Thursday, or tomorrow and Wednesday, I should say. So we're kind of rapidly approaching. This is something that on a test, I'll just give you a very basic one. Something like, this is really pushing everything together. Okay, now why I can't find x-intercepts. If I were to try to factor this, we talked about this on Friday. If you try to factor this apart, you pull out an x squared out of the first two, because I'm grouping, right? Because it is a cube graph. So if I'm grouping this up, that's x squared, that would be x plus 7. If I try to pull out a 2 out of this back, even a negative 2, it's still not going to matter. Like, they're not going to be the same parentheses. I can't even factor this thing apart, even though I know there's x-intercepts. And that's what we talked about on Friday. Is like, how would you do a problem where you can't factor, you can't do quadratic formula, the table thing takes too long. That's when the rational root theorem comes into play. Okay, so let's talk about the rational roots. All right, rational root theorem. What we need to discuss is how to actually calculate it. We talked about this Friday. The differential quotient stuff we did last Thursday. So we're going to kind of mix everything together here. Okay, rational root theorem. What's my back number over there? 40. What's the front number? 1. Okay, you have to take both those numbers. Notice the back number over the front number. That's how it always works. Now, what we need to do is break these up, and I need the factors of every single number. So what is the factor of 40? Like, what are all the numbers that multiply to 40?
2
and 20.
2 and 20.
4, 10.
4 and 10.
5.
5 and 8.
I think it's 7.
What's the last one? Any others?
No.
I think that's pretty much about it. I can't think of anything off the top of my head that would be actually going there other than
0.5 and 80.
What?
0.5 and 80.
No, I can do that. I'm no decimals. We're gonna stick with random numbers here. All right. On the bottom, what are all the
1.
Okay, yeah, 1. Okay. Now, if the bottom was bigger, we're gonna look at one of these tomorrow, where if the front number is larger than just 1, you have to make every combination of those, and that's what makes this problem really, really difficult. So, what you do, find all the potential rational numbers, all the potential x-intercepts, zeros, roots, whatever you want to call them. You take the top number over whatever bottom numbers you have. So you might make different combinations. So 1 over 1, and it's plus or minus. 40 over 1, that's just plus or minus 40. 2 over 1, plus or minus 2. 20 over 1, you guys get the idea. Eventually up to 8 over 1. Okay, some of these numbers might work, some of them don't. So, I want to assign certain people problems in here, certain number in here. I want to find one that actually does work. And if we find one, we can go on to the next part of it. So, what I mean by finding, we're going to do what they call synthetic substitution. Now, I always find this funny. This is the term that every textbook uses. There is no reason to have this stupid term. The books all have it. It's called synthetic substitution. You take all these numbers, you plug it back in, you see what happens. So I'm taking my function, that thing over there, and I'm plugging in a number like, let's say, positive 1. And I see, does it actually work? What I'm looking for, does it give me 0? That's what I want to have happen. Well, here's the thing. They don't need to call it synthetic substitution. It's just evaluating the function. It's plugging in numbers and seeing what the y value is. Because these are the x numbers you're plugging in, and I'm looking for a y value of 0. That's all I'm looking for. So it's evaluating. I don't know why they had to come up with some new term called synthetic substitution.
So this is one of the options for trying to find the x.
Trying to find x-intercepts. Yeah, so this is the whole purpose why we do it. It's because that problem was non-factorable, and I do not want to do a table. And this will guarantee it narrows down my numbers, so I don't have to make a huge table to find all of them. I can just immediately get one, and that'll eliminate to the others. Question?
This is just gonna find the x-intercepts.
Just x-intercepts. I know it seems like crazy, like that's all it's used for, but it's super accurate when you do it. And like you get used to like, I always check the small numbers first. Like I want to try 1, -1, 2, -2, 4, -4. Eventually one of them works. Okay, so here's what I want. Read it, plug in 1, type it in the calculator. Try -1. Try 2. Vansky, try -2, try 4, try -4, try 5, try -5, 8, -8, 10, -10, let's go 20 back there, -20, let's go with 40 and -40. Yeah. So, all you have to do is, what I'm doing is like, if I'm plugging in the 1, because I don't know who has 1. Okay, you're plugging these numbers in, so it's doing this. Whatever number I told you, that's the number you plug in to all the x's. And what I'm looking for is the first person that can find a 0 after you can enter in a calculator. I just need one person.
Can I say?
Okay, you got one?
Yeah, -4, -5.
Okay, stop. No, stop. Just -4. That's all I need. That's all I care about. Okay. Do we understand that we found 1? Okay, I don't know whose number that was supposed to be, but we found -4 work. Okay, so now that we found 1, again, obviously, like, why doing this? Like, a lot of you are like, well, we found all of them. If you're doing this by yourself, all you need to do is find 1. Okay, and you found another one? 2. Yeah. Okay, so we're going to eventually see that those are all 3. Okay, because when you look at this problem, what's your biggest power?
3.
So there should be 3 x-intercepts, in theory. Now notice, potentially. It doesn't have to, but it could have 3, like what my drawing's doing. It's actually hitting the x-axis 3 times. Now, the problem we're going to look at tomorrow, and why I'm having you do all of this, is because tomorrow, you will not have 3 x-intercepts. You might only have 1 or 2. And that's what we're going to look at. We're going to look at why would that happen. Okay. So, what was one of the numbers we found?
-4.
Okay, let's stop there. So, let's say you're doing this by yourself. Boom, you found -4 work. Here's what we do. Now, I know this seems really weird. -4 is one of those numbers that works. So, this is the parenthesis that represents -4, by the way. this is what represents -4 as one of my x-intercepts. It's x plus 4. Okay, we're gonna try to find the other two. We already know them, but we're gonna try to find them. So what do you do? Now that you found one, you synthetic divide it out. So I'm gonna go through the top of this list and write down all the leading coefficients. 1, 7, 2, -40. And I'm gonna divide the -4 out of it. This is what synthetic division's made for. Okay, so if I drop the 1 down, you drop it straight down. You multiply by the number in the box. You add straight down. You multiply by the number in the box. You add straight down. You multiply by the number in the box. You add straight down. And this is how you know you did it right. It should give you a remainder of 0. So -4 did work. Now, the best news about doing this, why we do this, is because what's left are the rest of the x-intercepts. So this, the biggest power is x to the third. When you synthetic divide, it goes down 1 power. So this will be x squared. This will be x. That's a constant. There's no remainder. So that's how you know you did it right. X squared plus 3x minus 10. All we need to do is factor that apart. That thing is factorable if you get down. Now, if it's not, I'll show you that here in a minute. But it should be factorable if we found a number that worked. And so at this point, I can factor this apart and find the last two. So this could be plus minus x and x. You break down 10 into two numbers that multiply to be 10, but they're going to add to give you the 3 in the middle. It's going to be 5 and 2. The 5 has to be positive, the 2 has to be negative. So it looks like my other answers for this problem, these are my other x-intercepts, are going to be -5 and positive 2. Does that make sense?
Yeah.
Okay, now notice, I couldn't do that in the very beginning of that problem. But it worked out to be nice numbers. So that's where these x-intercepts are. In fact, I tried my best, even though the drawing isn't accurate. This was -5, this was -4, and this was a positive 2. Now, here's the funny thing. How I knew that these were the problems, what you're seeing right there is how I made up the problem. I just picked 3 prime C's and I multiplied it out, and that's what I wrote on the board. That's all I did. So I knew what the x-intercepts were before I started. Now, let's say you're doing this problem and you cannot somehow, like, you get down to that problem right there and you can't factor it apart. You have that mental lapse, you just can't do it, or maybe the numbers are non-factorable. So now what we can do is we can do the quadratic formula. And that's the part I said I want to intro today, kind of walk you through it one more time. This is something you've probably done a lot in Algebra 2, but a lot of people didn't know what it's for. You just do it all the time. All right, so let's talk about it. Okay, here we go. So if that's my problem over there, x squared plus 3x minus 10. And let's say I can't factor this thing. I can, but let's say I can't. So I'm trying to find the last two x-intercepts. This number is A, this number is B, this number is C if I put it in descending order. And now you just do the quadratic formula. -b plus or minus square root. B squared minus 4ac.
All over 2a.
All over 2a. All right. Now, what that whole formula is for is to find x-intercepts when you can't factor. That's all it's for. So when you get down to the reduced function, we can now pull them apart. I can't do it in the beginning of the problem because the beginning problem was a cube. It's only good for squares. But plugging the numbers in, and I'm going to show you the shortcut. So again, hopefully you're writing this stuff down. So this is going to be -3. Again, my b is a 3, so it's -3 plus or minus 3 squared minus 4 times a times c. And notice that my c was a -10. Some people always forget that. You have to actually use the signs that are in front of it. And we're going to divide by 2 times a. So this will give me my x-intercepts. Here's how you know if you were having that mental lapse where you couldn't factor it even though it should have been able to, is right when I start solving this and you see that it turns out to be a nice pretty number. This is like a red flag in my head. So if we start doing all this work, you have -3 plus or minus square root. This is going to be 9. And right here, -4 times 1 times -10 is positive 40. And this is all over 2. This is the big red flag in my head that you can't factor. Because what's 40 plus 9? 49. And that number is a perfect square, right?
7.
Yeah, it's 7, right? If this number that you're doing when you do the quadratic formula turns out to be a perfect square, like 9, 16, 25, 49, 36, those numbers, you should have been able to factor in the beginning.
Nick Dyer,
It's a red
please come
flag.
to the office. Nick Dyer.
That number is called a discriminant number. Sometimes in algebra 2 they talk about discriminants all the time. That number should tell you if it's factorable or not. Okay, so since it was 49, it is. Now, you've already went past the deep end. You've already went this far. We might as well just finish it and find the last two numbers, even if we already know what we factored them out to be. So this turned out to be, the square root of 49 is 7. So it's going to be plus or minus 7 over 2. And this turns out to be the two numbers you see over there. Because 3 plus 7 is 4, and we divide by 2. So it's 4 divided by 2, which is 2. Or negative 3 minus 7, which is negative 10, and we divide by 2. And so that turns out to be these two numbers right there. That's what we have the quadratic formula for.
Why would someone do that?
It's when you can't factor it. So like we did all that work, and somehow, like, let's say that this was a 10, but in the middle this was 14. Like, it wasn't possible. Like,
Then
you
you have
did
to
all
plug
the
it in.
things, so you have to do that formula to find the last two, because the last two are decimals. They weren't pretty numbers like 5s and 2s and negatives. Okay.
Like, how does someone just come up with the quadratic formula and just know this doesn't work?
Okay, so good question. Like, where did it come from originally? Like this concept, like of this thing, it's when you complete the square on a quadratic formula where there's just variables. You complete the square, you move something over, add numbers to both sides, take the square to the other side, you complete it. If you ever didn't complete the square, I think you probably did algebra 2. That's where the formula comes from. It's just doing all the process of completing the square and just ends up being the formula on the other side. It just works when you actually solve it. So, a lot of people, like, you see it, you probably have seen it once or twice, you just didn't realize that's what they're giving you.
Yeah.
So-
So it's just like that whole process just in one equation.
Yeah.
Okay.
Now, I'm not even done yet. We're at the halfway point.
Oh.
O is right. We're only halfway done with my problem now.
Wait.
Okay, it took me 20 minutes to get
You found the
halfway.
x-intercept though, so
Yeah. Now we have to find the hills and valleys. This is the steps we did on Thursday last week. I made sure all the videos are online. I had to go through the website and fix a couple settings that I must have tweaked. It wasn't displaying for about the last week and a half-ish. They're all there. I made sure of it. I even checked this morning. Every video is showing up. They're all there. I must have had some setting where it was just hiding everything. You had to be a member. So I unchecked those and it's all working now. It took me forever to figure that out. All right. Anyway. So, we're halfway done. We found all our x-intercepts. We know that it's not symmetrical because we know by the x-intercepts it's not. We already found all the turning points. It turns twice because take the power minus 1. Fine, whatever. The last step. Find the relative max and mins for those hills and valleys. I can kind of guess that the numbers are roughly going to be in between here. So like when we find the hills and valleys, I know that it's going to be in between 4 and negative 5. So about negative 4.5-ish. That's where like a hill or valley will be. It'll be close. Over here, it's whatever numbers between 4 and 2. Sorry, negative 4 and 2. So that number, I don't have this drawn to scale, is actually negative 1. Negative 1 is roughly the number between negative 4 and 2. It's like the halfway point. So the valley is over here. I have it drawn wrong. So the valley's on this side. But it's going to be close. It's not exact. Because it's not the perfect middle of these, because these graphs go everywhere. Okay, so what we're about to do is some serious math. I want you to write this down. This is something we did in the last chapter test. And yes, I'm going to make you do it on this chapter test, if you're not paying attention. Because it's worth a lot of points. So, here's how you do it. I'm going to get rid of this. Does everyone feel comfortable with the quadratic?
Yeah.
Okay, that's it in case you can't factor it apart. Okay. And there was another rhyme or reason why I brought this up, and you'll see it here in a minute. All right. Okay, what we're doing here, before I start with this monster of a problem, because I'm at the halfway point, we're trying to find the number for the hill and valley. And all I'm looking for in this next step is to find what x number will give me the peak for the hill and valley. That's all this is doing. So I know that what I'm about to find is a number around negative 4.5 and a number around negative 1. It's going to be close. And that'll tell me where the highest and lowest point is on those graphs when it's oscillating up and down. That's what we're doing, okay? So, I'm gonna do this math for you. You need to see it at least once. Okay, we're good? All right, here we go. This is what we talked about on Thursday last week, so if you weren't here, you probably should be writing this down. It's this formula that was on your last chapter test, but with one slight modification. Okay, it's called the differential quotient. So, the differential quotient is used to find basically slope. And what we're going to do is eventually, when we find slope, I'm going to eventually plug in zeros for all these h's. So we're going to approximate, okay, at some point when we do all this work like we did in the last chapter test, what happens when h is 0? So when I get closer and closer to a hilltop where slope is literally 0, the slope is a horizontal line there, and down here. Everywhere else slope is positive or is negative. But at zeros, that's what I want to find. And so that's what we're going to look at. This is not easy. You're about to see some serious math. I already know the answer going in, which is the worst part because I know the shortcuts from Calc 1. So I already know the answer going into this. What we're about to find with all this serious math. Eventually, I'll be coming back over here, and we're eventually beginning to be finding this. Like this, I'm just pre-setting up. I already know it, and this is the worst part of it. I know what the slope is. Okay, we're gonna come back to that thing I just circled over there. So here's what we do. I'm taking my function and plugging x plus h's into this thing. So limit as h approaches 0. I'm taking this whole function here. I'm gonna take the whole board to do this. I'm taking that thing and plugging x plus h's into it. That's what we did in the last chapter test. X plus h cubed plus 7 times x plus h squared plus 2 times x plus h minus 40. There's the first part, that's just doing that part.
Wait, how come you have the x plus h cubed there?
Because that was my original problem, I'm plugging all x plus h's.
Oh, okay.
I'm doing the original problem. Then I'm going to subtract the original function. The original function is x cubed plus 7x squared plus 2x minus 40. And this is all over h. Now I have to actually distribute this power, like not distribute the power of 3, but actually FOIL 3 parentheses together in my head. Just FOIL 2 parentheses, that's x plus h times x plus h, then distribute the 7 over it, distribute the 2, distribute the negative sign on the back, add up the like terms eventually, divide everything by h, and eventually take all the h's and plug zeros in for them. At the end. You can't do it in the beginning, so you can do 0 on the bottom, you can't divide by 0. You see why this is big, menacing? Alright, I'm about to do this. I'm going to do this in the super abbreviated version because the worst part is I already know the answer, but you have never seen this before. So, here we go. Foiling this out, I'm going to FOIL 2 of these out together right away. That's x squared plus 2x h's plus h squared. That's foiling 2 of these parentheses out of the 3 of them. I still have to multiply by the third one. I can't do that in my head. Alright, back one. Now I'm going to distribute this, like FOIL this together and distribute 7 at the same time. I can do that in my head. 7x squared plus 14xh plus 7h squared. That's this part. Distribute the 2, so I have 2xh, or 2x plus 2h. Then we have the minus 40. So what I've just done so far is basically this part. Distribute the negative sign in the back, negative x cubed, minus 7x squared, minus 2x plus 40, all over h. And eventually I have to plug when h eventually approximates 0. I still have to FOIL this first one out. Yikes. So, distributing this, like foiling this out, this is going to be x cubed plus x squared h plus 2x squared h plus 2xh squared plus h squared x plus, let's see, boom, 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 boom. I'm at that, and now I'm at h cubed. So that's this whole thing being foiled together. There it is. I still have the 7x squared, 14xh plus 7h squared plus 2x plus 2h minus 40 minus x cubed minus 7x squared minus 2x plus 40.
Can you just type in the decimals?
Nope. And funny thing is, it shouldn't be lost because we did this in the last chapter test. So, all right. Now, if you did this right, So I foiled everything together, distributed everything. Yeah, it's big, it's menacing. You didn't keep up. Sorry, foil it on your own. Everything without an x should go, or everything without an h should go away. That's how you know you did it right. X cubed, 40, 2x, 7x squared, 7x squared. Everything without h's should go away. That's how you know you did that right on the last chapter test. I didn't warn you that. What I'm left with is a bunch of things with h's. I can combine some of them. So some of them, like I have 1x squared h, 2x squared h, that's 3x squared h's. When I add those up, these add up to be 3x h squares. That's an h cubed by itself. That's a 14xh and a 7h squared and a 2h. And that's all the h's. And this is still all over h, so I can't get rid of the h yet. And I still have to approximate when h makes 0. Now, last step, last two steps. God, this is going well. Divide everything by h. So I divide everything by h because that's a log division. And once I do that, then I can plug in zeros for all the h's because there will be no fraction left. So I'm allowed to plug in 0 then. So if I divide everything by h, here's what I'm going to get. And eventually I gotta plug in h is 0. Okay, so if I divide everything by h, that'll be a 3x squared left. This will be a 3xh, because one of the h's cancels out. 3xh. One of those h's cancel out, that's an h squared. This will turn out to be 14x, because h cancels. Divide an h there, that's 7h. And plus 2, because I divided h off. Now that I have that, here's the worst part, because I knew what this was going to be before I started. So I'm right there. If I plug in zeros to all those h's, what happens to this thing? This turns out to be 0. That one, this one, those all turn out to be zeros. So what I'm left with is what I have in the press here over there that I circled earlier, but I knew the answer. So we did all that work. We found that. What is that stupid thing over there? This thing, because that's, after clicking all the zeros, that's what I have. This thing. What is that? That's the x's that will give you your hills and valleys. Because I knew the answer was going to be before I started. So, to find the hills and valleys from that thing, you either try to factor it apart. That thing is not factorable. Because that has a 14 in the middle. I can't break it with 3 and a 2 to make 14 in the middle. So, guess what we have to do on that problem? Quadratic formula. Because that's the whole rhyme and reason. Yes, we went full circle. Why did I show you the whole quadratic formula on the problem that we didn't have to do it? It's because of this part. You had to see it at least once. So, the quadratic formula. To find all these x's that will give you the hills and valleys. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. This turns out to be negative 14 plus or minus square root, that's 196 minus 24 all over 6. This turns out to be negative 14 plus or minus, that's the square root of 172 all over 6. The square root of 172 is 13 something, 13 point something, because 169 is 13, so it's 13 point something. So, oh, that's a 14 out front, not a 4. 14. So if you're going to take negative 14, add 13.2, and divide by 6, you get like a negative 0.15. There's one of the hills and valleys. That's taking negative 14 plus whatever the square root of 172 is divided by 6. Or, the worst part is, negative 14 minus 13.2, and you get negative 27, you divide it up by 6, you get negative 4.51. These are your two x's where your hills and valleys are. I already said that. Negative 4.51. Negative 0.15. That's where your hills and valleys are. If you actually want to find where the hill and valley is, you actually take both of those numbers, you plug it into the original problem, and you evaluate it. And I'll tell you where that hill is. In fact, the hill on this right side over here, it's down by negative 40. If you plug it on the right side, it's up quite a ways. So you have to actually plug those numbers in. Questions at all about what I did? tired? We're done. So, whole problem. So, okay, that was a single problem doing everything on. One. Now again, in Calc, you learn shortcuts. You can do it in a couple seconds in your head. But you guys aren't there yet, so we have to still work on that process. If I was assigning a couple of these in the homework, the max I'd probably do, maybe about 2 or 3 of them. But I would make sure that they're factorable, or you have to make sure that you can do quadratic formula for every bottom.
All those
Yes.
first.
I'll do a square. Where there's only one. Because that's what you did in your last chapter test. That's why that problem is very good. Question.
Wait, I want to use Kyle as a resource.
I'm sorry, anything. I want this to be a human calculator.
He's pretty good.
I think maybe you should collect it.
Take that back.
Bring it back. We're gonna do one of these.
Take it back.
So stupid, we're not.
You're basically saying half price.
I think the only thing that's gonna teach him is not half.
So,
Half bread?
10 minutes.
I don't need
But if I come in there like super low.
Because I am. I swear to God. On the Holy Bible.
Okay, now it's my call moment.
No, because I know it's serious. Yeah, I did 4.
and I kept using it over and over.
I see what's happening. Okay. Okay, why does this section make sense?
I'm telling you, it's pretty accurate.
I lost track of the floors. I ended up
With my dad.
It's the same dad.
That was so funny.
Simple check box. I've never looked at before. I must have just tried why. It was hiding.
I did it earlier, and then I accidentally forgot to
Dad.
do that.
Oh, dude,
Her daughter is in 40, so I lost track of that. So I had to go instead of just 2. So is that
My younger sister.
Just doing that part. Because I turned away.
Name's Olivia. I 20 minutes outside.
Dude, it feels like 2000. It was like for years.
Josh. Dave Snapchat me the other day. I miss you guys.
40 million minutes ago.
He was trying to come in the mall with us.
I don't know how to do this.
Dean came with us.
I know you're one.
But he couldn't come away. I miss you guys.
You're just doing the accent.
I wish I could have
He is on that.
Just ask who was there. Why did you just go to business
My mom and
class?
Josh's. They didn't have it.
Who did you enter business?
Dean and Dave.
Who's that?
And, but,
No.
Dean and
Hey, what?
I don't know.
Ian, what's that
Which
class,
one?
Mr. Johnson?
Like, you guys are both of them.
12 and
Oh, no.
9. See,
Yeah.
exact 10 now.
This way, we're going down.
But it's stupid.
Dean does.
So,
I know. I don't know. It's right like
so
that.
pass through 0.
They used to.
I'm doing 10
So
minutes.
pass through
Little,
0.
little.
For 13 Wednesdays.
Dean.
9. It's 90 minutes, not 100 minutes. You're an idiot.
He's the same. He will do anything.
Bryce.
Yeah. He will do it. I know.
He's just such a big opposite.
No, that one's a
He was
power
at
force.
Spillman's house. And Brady had to go help him.
He doesn't
He was in
have
trouble. And he's like, oh, I'll help.
Is that right?
And they go, hey, you don't have to do that. He goes, no, I won't. And he goes,
Yeah.
okay. And he paid, and he goes, no.
Now, please.
And he just went out and shoveled it. He did like 90% of it.
I don't understand.
Oh, so
And I feel bad for his dad. He just expects so much from me. It's not fair. He expects way too much. He expects what my mom expects from me. And my mom expects what God says.
And we know what the final answer is, because the answer will be.
Considering I've had a lot
Eventually, we have to maybe change it.
It's actually will end up being.
He's my half bird.
Didn't grade?
He's got a lot of problems. He's got a lot.
They always go up.
Joe, I was
You can still back.
This is a representative.
You can break up the text because we're just.
He's like this.
No, I don't think I'm ever gonna do my life. I
Wait, who did you fight? Braden. And then I was like, oh, Braden won. He shot one good punch.
Nobody, that was like second hardest thing. We were trying
And one of them has to make a sound.
Guys?
The fight lasted like 1 minute. He's killing himself.
Are you still on the camera?
Yeah.
That's what I'm saying.
Because you said I'm going to live in a
Do I have to make a positive or negative?
I bet it's not even in
Be a
there.
positive or
I
negative.
bet it's just how it's written.
Because this will make negative, positive,
What am I gonna use this for my life transport? Tell me now.
give me the.
You're funny. Why is it back to it's the IO.
About
Why are
what?
you in this class then?
What were you gonna say?
I was like,